So this will be the solution to question 12 on the 116 exam 1, winter 21, and this question moving into the end of chapter 15, looking at the Doppler effect, and specifically the question context is looking at a source moving toward a stationary observer, so that's the police car moving toward this, the group of students that are arrested, and then the observer moving toward a stationary source, that's a group of students in a car moving towards a stationary police car that has the siren activated. So looking at these two expressions and which one gives us sort of the larger perceived frequency. So that's what the sort of question was getting at. So yeah, 3 physical and 16 students are discussing two cases involving the detection of a sound from a police siren. Again, as I mentioned, case 1, the students are in a car that's moving with a speed of 45 miles an hour toward a stationary police car. So that's a moving observer toward a stationary source. And in case 2, the 3 students are arrested. Signing arrest, and a police car approaches them. I think in the second version that's presented here, I sort of flip case 1 and case 2, I believe, or I think that's what I did. But I'll go through the reasoning for both, that you can sort of figure out if you got the second version. I either flip the cases, or I sort of jumbled the answers for student 1 and student 2, what they think is true. Okay, but we can definitely go through the reason that it should be clear which is the answer is correct. I also know that this is a very similar question to video question 3 from lecture 8. So it's very similar to that question. That was sort of I was building on for the question. Okay, so in case 1, we've got the moving observer, so the moving observer towards a stationary source. So if we go back here, we've the observer moving towards a stationary source. This is sort of case 1, and this is case 2. So we want to compare both. So if I walk through this algebra, so let's say that F1 is equal to 1 plus the V observer divided by V times F source, and F2 is equal to F source divided by 1 minus V source over V. Okay, so we can do a little bit of algebra here, and the question, I was hoping maybe some sort of reliance on maybe this particular question. It does work out whenever the source is moving. If the source is moving, they're both, in the sense that the V observer and V source are the same, it always works to be larger for when the source is moving toward the stationary observer. But let's work through the algebra to see why that is true. So I'm going to take this expression, and that Fs equal to F1 divided by 1 plus V observer over V, and then plug that into this equation here. So F2 is going to be equal to F1 divided by 1 plus V observer divided by V, 1 minus Vs divided by V. So that's our algebra so far. It looks a little bit messy at the moment, but we can make some simplifications. So we know that V observer is equal to V of the source, both at the same speed, both 45 miles an hour. So I know V0 over V is equal to Vs divided by V, and I'm just going to call that quantity X, because it's going to be the same ratio in both. So if we take our algebra here, we have F1 divided by 1 minus X, 1 plus X, times 1 minus X, which you might see that as a difference of two squares. So we can make this equal to, this will be equivalent to F1 1 minus X squared. That's sort of the, since this is the difference, 1 minus X squared is the difference of two squares, which can basically equate to 1 plus X and 1 minus X. So I know that in this particular case, so sort of providing a solution to F1, 1 minus X squared. 1 minus X squared will be less than 1. The V0 over V, or the Vs over V, will be a small number. 45 miles an hour is about 20 meters per second, so it'll be a small fraction, but 1 minus that fraction squared would show that F2 is larger than f1. Not by much for that particular speed, but definitely larger in the case in which the source is moving toward the stationary observer rather than the observer moving toward the stationary source. So the person who believes that, I think maybe I kept the cases the same and switched what the students believed. So the student who believes that the frequency in K1 in which the police car is moving towards the stationary students, that's the one in which the students will perceive a higher frequency. So in this particular question, it's student 2. Okay, yeah, so a challenging question. Of course, you could plug in the values, that would be completely valid. If you wanted to convert the 45 miles an hour to meters per second, 45 times 1609 technically meters in a mile, you could round it out to about 1600 meters, divide by 3600 seconds. You could plug that into those equations, solve for the perceived frequency in terms of the source. I think it's like 1.06 or 1.062 to like 1.05. But that's sort of the question was looking at. If you have observers moving at the same speed as in one case, and then the source moving the exact same speed in the second case, the case in which the source moves gives us a larger perceived frequency. So that was the key to the question. So F2, case 2 will lead to a larger value. Okay, yeah, I'll leave the question there and follow up question 13.